Hello, my name is Rob Reynolds. Welcome to Mat-073. Today we're in Chapter 5, and we're going to be looking at Section 7, Solving for a particular variable within a formula. So this is a harder lesson than what most students realize, so be very careful with this. So we have all sorts of formulas. In the last video we're talking about motion problems, distance equals rate times time, and we actually sometimes had to solve for the rate. So we decided to divide both sides by time and come up with a new formula, and we said the rate was distance divided by time. Well, that's what this video is all about. Sometimes we give you formulas. I think you've seen this before, the conversion from Celsius to Fahrenheit or Fahrenheit to Celsius, and sometimes we have to solve for one variable in terms of the other, and same with things such that in physics. All right, so here are some suggested rules that the author would suggest. You can pause the video and read through those if you think they're helpful. First example, solve for y. So the goal is to get rid of the fractions. And we've learned how to clear fractions by multiplying both sides by the common denominator, which would be this t plus ay. So I'm going to multiply both sides by t plus ay. And the nice thing is that when you do that, all of this will cancel. And on the left side of the equation, the only thing I have to do is distribute this r, and I'll do so. So this will make it a tr plus ray is equal to, and the only thing left over here is this at term. So the goal is, if you're going to solve for y, the goal is to get all the variables on the same side. So this is the variable that I'm trying to solve for here in yellow. So I'm going to try to undo what's happening. And so before you undo multiplication, so the rules are, please excuse my dear Aunt Sally PEMDAS. This is the order that we do things in. But the order that we undo things in, there are exceptions to this, but what I'd like to try to undo first is addition and subtraction. So don't worry about the multiplication. Let's subtract off tr from both sides. So ray is equal to at minus tr. And then lastly, I'm going to divide through by this ra term. And there's my final solution. All of this cancels, and y is equal to this. Let's see if the author agrees. Yes, they might have worked it out a little bit differently, but the result is the same. Let's try again. There's a lot of words here. They tell you what this all is defined for, but basically they're giving you a formula and they say solve for capital D. And the hard part is sometimes there's smaller d's because the small d stands for the diameter. And, well, I guess they're both diameters. Diameter of the Earth, and then the large d is the diameter of the Sun. So there's a couple diameters floating around here, but you're going to solve for the large d, diameter of the Sun. And again, the same principle. Let's get rid of the fractions by multiplying both sides by the common denominator. Big D minus little d. So over here I'm going to distribute. Again, I'll get dl minus dl. And everything over here cancels. So except for the only thing left I have is dr. So again, trying to solve for capital D, get all the capital D's on the same side. Well, there's only one capital D. And then try to undo what's happening to that capital D. So I'm going to add dl. And of course, you can't combine these. These are not like terms. So capital DL is equal to dr minus dl. And then the last thing I have to do is just divide through by capital L. So D is equal to this term. Now just be careful. One of my pet peeves is when students try to cancel these L's. You can't do that. That's part of a sum. You can only cancel what you may be thinking is when you have products. If I had something like this, then I can cancel. This is okay because it's not part of a sum. There's nothing out here that you can factor. So if it's part of a sum, don't start canceling. So final solution, author agrees we don't want to cancel those L's. Third example, reading through this, it says solve for a sub 2, and we've got an a sub 1 floating around too. I think when it's a fraction, the easiest thing to do is to cross multiply, so I'm going to let the pink diagonal equal the yellow diagonal. So in this case, I'm going to get f1a2 for the pink diagonal should equal the yellow diagonal, a sub 1 f2. And the goal is to solve for a sub 2, so I'll undo what's happening to a sub 2, which is being multiplied by f sub 1. So I'll divide by f sub 1, and that was a fairly easy, well, compared to what we were looking at, that's a lot easier example. I think what maybe the point here is you don't want to cancel those f's, because even though we have an f sub 1 and an f sub 2, those are two different variables just like x and y. So this one says solve for r sub 1. So the common denominator, oh my gosh, is capital R, small r sub 1s, small r sub 2. And you're going to multiply that on both sides because it's an equation. You can do whatever you want as long as you both start both sides. But then I'm going to distribute that to every term. So it looks like I've multiplied the left side twice and the right side only once, but I didn't. I multiplied both sides of the equation by a red, capital R, r sub 1, r sub 2, and then distributed that to every term. All right, so the nice thing is hopefully things will start canceling here. So capital R goes with capital R sub 1s will cancel, and r sub 2s will cancel. So let's see if we can pick off what's left. 1 times all of this on the left side is r sub 1, r sub 2 should equal, again it's a 1 times this, so capital R, r sub 2 plus capital R, r sub 1. And we're trying to get r sub 1. So this is the first time that you've seen, in this video at least, that I keep saying put all the variables that we're trying to solve for, which is r sub 1, put all those variables on the same side. Well, I think this is the first example that we actually have two of them. So the goal is to put them all on the same side and factor. So I'm going to say r sub 1, r sub 2, this is already over there. I'm going to subtract this off, minus r, capital R, r sub 1 is equal to capital R, r sub 2. So I just subtracted this term and threw it on the other side. So since you have two of these r sub 1s, I'm going to factor them out. And that's the trick that will create just one r sub 1, what I'm trying to solve for. So r sub 1 will equal, if I divide through that parentheses, r sub 2 minus r. Let's see if the author has a similar solution. Again, you could pause the video and see how they worked it out. Last example, let's multiply both sides by the common denominator, which is e plus nr, e plus nr. All of this will cancel over here, just leaving me with ne. But over on the left side, I'm going to distribute this to every term. So I've got ei plus nri. And then remember, I'm trying to solve for e. So this is the last example. Hopefully you catch this. The goal is, whenever you have two variables, try to throw them all on the same side and factor. So I'm going to do the same thing, ei minus ne. Oh, and I got to throw this over on that side, so it's a negative nri. So if I factor out an e, that's literally like dividing each term by e, and I'm left with I minus n equals negative nri. So over here I'm going to subtract, or excuse me, divide by the quantity. All of this will cancel, and my final solutions should be e is equal to negative nri divided by I minus n, and I cannot cancel anything because they are parts of sums. I hope you found this video helpful. Email me with your questions. Thanks.